One of the things we'll definitely talk a lot about in the rest of this course is the idea of a p-value, which is short for probability value. And this is the probability, if the null hypothesis is true, of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. Basically, in short, keeping it short to the point, a p-value tells you the likelihood that your null hypothesis is actually true. So if you get a p-value of like 0.73, it basically means there's a 73% chance the null hypothesis is true. So this will depend on what kind of test you're running, but not a big deal. Basically, there are three types of hypothesis tests you can run. There's what's called a left-tailed test, a right-tailed test, or a two-tailed test. And I'll show you in a second pictorially what they look like. A left-tailed test basically means that your HA statement has the less than sign in it. So as you can see right here, HA is mu less than some particular value. And pictorially, here's the normal curve. Basically, when you're doing a less than test, you're always looking in the left tail of this normal curve. Okay? And the shaded region represents the p-value of the test statistic that you're running. A right-tailed test is used for when you're doing a greater than test. So your HA statement will have the greater than sign. So not surprisingly, if I show you a picture of the normal curve, basically we're looking at the right tail of the normal curve. Again, the shaded blue region represents the p-value of that statistical test. And then a two-tailed test basically looks in both tails. Okay, that's a not equals situation. So you can see HA here, the population mean is not equal to a particular value. So basically, the probability or p-value is split between the two tails of the normal curve. Okay, together, add up both of those shaded regions, that gives you the p-value for that hypothesis test. But basically, the two-tailed test is for when you don't really know what direction you want to use for your alternative hypothesis. Okay, so let's say you're doing a study and somebody says out there that college students get 8 hours of sleep on average a night. Well, we might not know exactly if we think that we might have an idea that that statement might not be correct, but we might not know specifically if college students, sleep more than 8 hours a night or actually sleep less than. So in that case, a not equals test makes sense because we can test for both directions. We can test to see if they possibly sleep more than 8 hours or sleep less. So let's determine from these problems if they're a left-tailed, right-tailed, or a two-tailed test. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So we've done this problem before, and the key word there is that is, right? We think the proportion is 61%. That is the equals, that's equals for HO, and consequently HA would be the opposite of equals, which is not equals. This is a two-tailed test. You're going to look in both the left tail and the right tail. Car dealership announces that the mean time for an oil change is less than 15 minutes. So they're saying less than here. Our HA statement would have the less than sign. This is a left-tailed test. So our p-value is going to be in the left tail. A company advertises that the mean life of its furnaces is more than 18 years. Okay, more than is greater than mathematically. This is a right-tailed test. Okay, and there you go. HA has the greater than sign. So when you're doing a hypothesis test, basically for the rest of this course, okay, there's basically a rule of thumb that you can help figure out whether or not you reject the hoe or not. And basically, you compare the p-value that you get to the alpha level that's set in your problem. If your p-value is less than or equal to the alpha level that you're starting with, then you have enough evidence to reject the null hypothesis, or HO. If you find that your p-value is bigger than alpha, then you would fail to reject HO. And I should mention that alpha will always be given to you in your homework problems. The p-value will be something that will come out of your graphing calculator. So if, in this case, if your p-value is smaller than alpha and you reject the null hypothesis, and your claim was originally the null hypothesis, then you have enough evidence to reject that claim. Consequently, if you find that your p-value is greater than alpha, okay, you would fail to reject the null hypothesis. If your claim is the null hypothesis, then you would say there isn't enough evidence to reject the HO claim. Let's say you have enough evidence to reject HO. You find that your p-value is smaller than alpha. And let's say your claim that you're starting with is your HA statement. Therefore, in this case, you rejected the null, which is the opposite, so you have enough evidence to support your claim. And then on the flip side, let's say you don't have enough evidence to reject the HO, okay, and your claim was your HA statement. That means you don't have enough evidence to support your claim. So basically, one of these four statements will relate to your homework assignment, okay, depending on what your claim is. So let's look back at that extracurricular example. A school publicizes that the proportion is 61%. Okay. If you rejected the null hypothesis, which is our claim here, okay, how would we support that statement? Basically, our claim is represented as HO. If we end up saying we reject it, that we would say that there is enough evidence to reject that claim, that the proportion of students involved in at least one extracurricular activity is 61%. If, however, you don't have enough evidence to get rid of HO, then you would say there isn't enough evidence to reject this claim. Okay, well, what about if your HA statement is actually the claim, okay? How would you interpret your decision if you reject the null hypothesis? Well, if we reject the null hypothesis, that's actually good evidence for our HA. If HO is wrong, if we get rid of the HO, that means our HA is good. We like that. So ultimately, that would mean that you have enough evidence to support the dealership's claim that the mean time is less than 15 minutes. But if you didn't have enough evidence to reject the null hypothesis, that basically means we don't have enough evidence to support this claim. So when you're doing a hypothesis test, basically these are the steps that you follow. Okay, first you state your null and your alternative hypotheses. And then what I would add is that once you state HO and HA mathematically, right next to either HO or HA, which one is actually the claim in the problem. That'll at least help you when you're doing your homework assignments to figure out which, it'll help you determine your conclusion. Specify the level of significance, or alpha, in your problem. I'll either tell you in class what that is, or it'll be given in your homework problem. Typically, alpha, like I said, is usually 0.05, but they will tell you specifically what you need to use. All right. Determine the standardized sampling distribution and sketch its graph. So basically, sketch a normal curve, and if you're doing a greater than test, mark off where the shaded region should be, which would be the right tail. If you're doing a less than test, it should be the left tail. Then you calculate the test statistic and its corresponding standardized test statistic, which I'll show you how to do in the next slides. Find your p-value. That'll come off of your graphing calculator, and then use the decision rule. Okay, is your p-value smaller or equal to the alpha level? If it's not, we say fail to reject. If it is, we reject. And then afterwards, we're going to write an interpreting statement in the context of the original claim, which for the homeworks, they will be given to you multiple choice. So that won't be too bad. And that's basically it for wrapping up the introduction to hypothesis testing. And then in the next set of videos, I'm going to talk to you how to do a hypothesis test for not a proportion, a population mean. And I'll show you graphing calculator wise how you actually go about using the graphing calculator. Very simple. I'm very confident you can do it.